Ladies and gentlemen, congratulations on completing Chapter 1. Let's roll into Chapter 2. Section 1, you can see in your notes, I would write down understanding the concept of this thing called perpendicular. Perpendicularity. Now, before I give you the definition and roll into an example or two, let's talk about some things that intersect in this world. We're going to talk about intersecting things. I'm being very vague, but here's a couple pictures. There's an awesome intersection of roads. Now, God bless the engineers that do this stuff, because I'd have no clue where to even begin. I don't know where this picture is, where does someone in the world would know. They could probably tell me. But it's just really cool. So these things, don't misunderstand me. They're not intersecting. I mean, they're going over top of each other, but this point right here is where everything kind of culminates together. It's really cool. Here's another cool picture. Nice little railroad track. These railroad tracks certainly do intersect. I took a picture, a Google map of our wonderful here little this town of Mechanicsburg. I Google mapped our high school, so there's MASH. What up, MASH? Yeah, go get them, Wildcats. And you can see all of these roads around the town, they intersect. Hence they're called, this is going to blow you away, intersection. Whoa, they're the intersection. Wow. The intersection. How cool is that? They're intersecting. So they intersect right there. These two words, let me back it up, because you can see whether you know this or not. There's actually the town of Mechanicsburg. I'll zoom in more, sorry. So, I mean, all of these roads in here intersect at intersections. It's pretty cool. So there's a bunch of roads that intersect. Hey, check this YouTube video out that I saw of this thing called, it says crazy intersection, but check this out. I might play it twice for you. This, by the way, is not in Mechanicsburg. I think I was told it was in Vietnam, I think somewhere, but look at this crazy intersection. Look at, I'm sorry, it's really crazy. I couldn't imagine it being like, by the way, it's not like the lights were out in that particular thing. It's exactly how it is. Let me play it again for you. Look at that. This is only a 10-second video clip. You can go on YouTube and check out another one that's a lot longer and just see how crazy it is, but it just is a mess. I love it. Anyways, so that is a couple examples of intersections, and this is all well and good, but I need to cut back and do some examples for you of things that are more geometric. I mean, they're great to say, great, look at these things that intersect, but let's talk geometric-wise, geometry. So here's an example that you can write into your notes. Now let's talk about these specific things called segments. Well, I can certainly take segments or lines or rays and intersect them. Now you can see this right here. They are not intersected, but as soon as I intersect them, what I want you to notice is what pops up on the screen. Are you ready? Bam. I'll do it again. Bam. As soon as I intersect these two segments, you notice there is immediately 1, 2, 3, 4 angles that's formed. It happens every time that you take a line, a ray, or a segment and intersect another line, ray, or segment. Like this. Bam. Now, the only thing that could happen is maybe if this thing just kind of touches right there where point E is, you can see it, and that creates 2 angles. Not 4. I can't quite do it because this program doesn't let me. But the point is, these things intersect and they create 4 angles. But here's the important thing. Here we go. Here comes your definition. As soon as we intersect lines, rays, or segments, so much so that these angles all around this particular point of intersection right here becomes this special. Keep watching, keep watching, keep watching. We're getting closer. You're going to see something really cool happen. Here we go. Next one. Bam. Notice all 4 of these angles are 90-degree angles. That's right. They're an RIGHT, a right angle. As soon as that happens, as soon as you have 2 segments that intersect to form right angles, that, ladies and gentlemen, is your definition of perpendicular. So let's go back and let's write down the definition of perpendicular into your notes. So here it is. Bam. The definition of perpendicular: 2 lines, rays, or segments that intersect to form right angles are called perpendicular. Now what I did for you is notice this. I wrote it into a conditional statement form. If 2 lines, rays, or segments intersect to form right angles, then they are perpendicular. So that right there, ladies and gentlemen, oh look, it's a definition. And oh yes, if you're wondering, I wonder if I could use this in 2-column proofs. Absolutely you can, and we're going to here in a little bit. So, there's your definition. Now, you can rewrite this with symbols. Instead of writing the angles word, you can write angles like this. And actually, instead of writing this word perpendicular, there is a symbol for it. The symbol for perpendicular is just basically this. It's an upside down T. That's your symbol for perpendicular. So when you see that in your book, it stands for perpendicular. When you see this in your book, that stands for congruent. When you see this, it's segment. That is ray. That is line. Well, that is angle. This is perpendicular. Now, I gave you 3 examples at the bottom so you can see how I'm going to write this. And you can write these in your notes too. Example 1 says, look, I have line L and line M. My question to you is, are they perpendicular? I hope you're saying, no, Mater. And if you're not saying no, you're like, wait, why aren't they? Because I don't know that they're forming right angles. Because notice it says, if I have lines, rays, segments intersecting to form right angles, that's when I know that they're perpendicular. I don't know that they're right angles. So as soon as I put a little box in here, then we're talking perpendicular. So here's how you'd write this. Line L is perpendicular to line M. That's exactly how you'd write that one. The second one, are these 2 segments perpendicular? That's a question to you. You better say, we don't know that yet. As soon as you would know, if it was given to you, or maybe you could prove it somehow, if that box was in there, or you knew it was 90 degrees, well then game on. You would know that segment BA is perpendicular to segment AD, and you'd write it exactly like that. Okay? Over here to this one. Are these perpendicular? I think you get it by now. We don't know. If I put that right there and know that that's a right angle, then bam. We're forming right angles with this ray FL. Shout out to my Florida peeps. And my Pennsylvania peeps right here. So my ray PA. So how would I write it? I'd write PA ray is perpendicular to ray Florida. Just like that. Ray FL, not Florida. So there's your examples. You'd write it like this, or you'd write it like this, or you'd write it like this. Either way, you use this symbol, the perpendicularity symbol, to put between the 2 things, just like we use the congruent symbol in many, many other videos and examples that we've done. So let's now cut to a proof example, and I'm going to give you a little bit. Actually, you can pause this. I don't need to give you any time. Pause it and copy this down, and let's rock and roll, and let's do it. So you would know step number 1, whoa, hello. Step number 1 is AB, whoops, is perpendicular to BC. That is given information, so that should already be there if you didn't copy down already. I'm going to save room by putting these on the same exact line. So I have BC, boom, and you know this too. The reason is most definitely given, no doubt. Now, step number 2, what am I going to do? I'm trying to actually show my goal, my conclusion here is to show that B is congruent to C, those 2 angles. Well, if I ask you this question, how do we know at this point the 2 angles are congruent? There's really only 3 ways that we've used in 2-column proofs to reason this out. One is maybe we can show that they have the same measure. If we can show that they have the same measure, awesome, then that'll work. Another way is to maybe show that they're both straight angles. If we can show that both angle B and angle C are straight angles, then we know that they're congruent. The other option is to show that they're both right angles. So are they both right angles? I don't know. That's the thing. If we can show same measure, straight angles or right angles, we know that these angles are congruent. So I'm getting you to think through this. This is how you do these questions. Well, let's go look. Angle B, angle C. If I look at the picture, let's do some observation before we start proving this. Angle B certainly isn't anywhere near a straight angle. So I'm going to eliminate this one. Doesn't make any sense why I'd even try to prove both angle B and angle C to be straight angles, because they're not even close to it. Now, can I look at this and say, oh, that's definitely a right angle? No, I can't assume that. I cannot do that. So maybe I can show that they're the same measure, or maybe I can show B and C are right angles. Wait a minute. Do I know anything else, any symbols or any other known facts that's going to help me lead to one of these 2? My idea would be absolutely, and here's what you should be saying. I see this perpendicularity symbol. I see this perpendicularity symbol. According to my definition, that hints to me something about right angles. And by the way, that's a very good hint. And that's exactly what we're going to do. Why don't we show that angle B and angle C are right angles, and then once we show that they're right angles, then we can show that they're congruent. So let's do it properly. So step number 2, I'm changing colors, keeping changing colors. So I'll make this red O2. Ooh, nice. So step number 2, here's what I'm going to say. I'm going to say, since I know AB, this guy right here, should probably use a different color, but since I know AB is perpendicular to BC, that's what it tells me, right there in the given information. That means I can certainly conclude that this is true. Angle B is a right angle. Now you're going to say, why? Well, here comes my definition. If two segments are perpendicular, and I know that that's the case because it's given to me to be perpendicular. If two segments are perpendicular, then they, meaning the two segments, intersect to form right angles. Now, remember we talked about this in class. Ready? This piece right here must connect to something previously stated to be true in my proof. And by golly, I have it right here. That's the connection. I have two segments that are perpendicular. And then remember we talked about this in class too. Then this piece right here better connect with what we just stated to be true over here. And I have it right there. So if two segments are perpendicular and they intersect to form right angles. You could actually just say a right angle too. Either one's fine. So that takes care of angle B. The same thing, same argument, is going to allow me to say, well, wait, if DC is perpendicular to CB, well, then this angle here is also a right angle. And you need to state that, and I'm going to put that also in step number 2. So I'm going to put angle C is also a right angle. And by the way, I have that connection, right angle, both of them right there. And I have two segments that are perpendicular, stated right there, to be able to know that angle C is a right angle. So I have the pieces in the right spot. Now, am I done proving that these things are congruent? Nope, I'm almost there. I'm almost there. So what I have to do is now conclude step number 3, angle B is congruent to angle C, and I need a valid reason. How do I know that these two angles are congruent? Because they look like it? Nope. Because they're straight angles? Nope. Because I proved they had the same measure? No. I didn't prove they had the same measure. I proved that they're both RIGHT angles. So there is your reason. If two angles are RIGHT angles, this is the theorem, then they are congruent. And again, here we go. We got everything connecting right. I have two angles for sure stated to be right angles. Where? I have it right here, and I have it right there. There's my two angles that are right angles. And I have them stated to be congruent right there. So there's the pieces that connect the way that they're supposed to. That is really ugly. Sorry. Anyways, that's an awesome example. So we're going to practice this perpendicularity thing in class. Read through it in your book so you can get a little bit more familiar. Look at your sample problems. And we'll see you in class. Perpendicular later.